balancing half reactions in acid solutions. We're going to go through this step by step. Okay, we're going to take maybe 1 or 2 examples so that we can find out, we can learn how to balance half reactions in acid solutions. So let's use this example. Let's say permanganate, manganese, okay, and this, right, oxygen has a net charge. Let's say this compound has a net charge of 1 minus, okay, so these are half reaction, manganese 2 plus. Can you balance this? Okay, so we're going to balance this half reaction step by step so that we can learn how to balance half reactions in acidic solutions. So what we'll do first is to balance. We're going to balance the atom that is being oxidized, or the atom that is being reduced, and that is manganese in this. Okay, so we're going to look at the left hand side and we're going to look at the right hand side. So we can see that we have 1 atom of manganese here, then we have 1 here too. Okay, so we can say that manganese is is balanced. Sorry, you can say that manganese is balanced. So the next second step is to balance the oxygen. So we have 4 oxygen here, but we have none here. Okay, and so to balance oxygen, you don't just go and write since we have 4 oxygen here, you just go and write O4, right? That's basic thinking, right? That's an easier way, but you don't do that. To balance oxygen, you add water to that other side. Okay, to balance oxygen, you need to add water to the opposite side. So let's balance oxygen. So we'll have manganese, good, this manganese 2 positive, so we add water. So we're going to add water, right? Here we go, water. But let's see, we have 4 oxygen here, we have 1 oxygen here, so we want to balance this oxygen. So the only way we can get 4 oxygen here is to have 4 water, right? So we have 4 oxygen here, so we have 4 oxygen here, and now we have 4 oxygen here, so we can say that our oxygen is balanced. But since we introduced water, now we have introduced a whole new element into the whole mix, and that is hydrogen. So we must now balance this hydrogen. Okay, so to balance this hydrogen, we add hydrogen to this other side. So we add we have 4 hydrogen here, 4H2, so that makes a total of 8 hydrogen. So we're going to add 8 hydrogen. And if you remember, if you saw our video, if you watched our video on the rules that govern redox reaction, we told you anywhere we have hydrogen, that's the second rule, right? Anywhere we have hydrogen, hydrogen goes with 1 plus. So now we've balanced the hydrogen. So the next step in balancing this, it will be to balance the charge. Okay, we have to balance the net charge. Okay, so if you look at this part, we have this has a net charge of 0, this has a net charge of 0, but we have 2 plus here. Okay, then so on our right hand side we have a total of 2 positive, while on our left hand side we have a total of 8 positive plus 1 negative. So we have a total of 8 plus minus 1 will give us 7. So we have a total of 7 plus 7, right? Here we have plus 7, while here we have a total of plus 2. So we have to balance this charge. We have to have the same number of charge here. You have to have the same net charge here and the same net charge here. Okay, right and left must be balanced. So for us to balance this charge, we have to find a way to reduce this so that the net charge here has to be positive 2. So to reduce this, we introduce electrons. So let's rewrite this. So we're going to introduce electrons. So we need 5 negatives. Okay, we need -5 to reduce +7 to positive +2. So we add 5 electrons, right? Plus 8 hydrogen plus, good, then plus our manganese O4. Okay, so this is our right hand side. Now if we calculate, now here we have 5 negative. Okay, so we'll have 5 minus 5 plus 8, so we have 8 positive here, plus -1. So we're going to get, that will give us +2 on this side. Now on our right hand side, we have manganese 2 positive plus 4 water. On this side, we have a net charge of 2 positive. So on this charge, we have a net charge of 2 positive. So you can say that this equation is now balanced. We have a net charge of 2 positive here, have a net charge of 2 positive here. So we have balanced this equation. Let's look at another example. Let's see. Okay, let's look at example 2. Let's try to balance something like, okay, let's say SO2 has a net charge of 0 here. There's a half reaction. Let's okay, SO4 with a net charge of 2 minus. Okay, first thing, we're going to solve it the way we solved the other one. If you look at this, this has a net charge of 0, this has a net charge of 2 minus, but we don't balance charges first. We first balance the elements, okay, that is being reduced, the atom that is being reduced or oxidized. So sulfur is 1 here, sulfur is 1 here, so sulfur is balanced. Next, we need to balance oxygen. We have 4 oxygen here, but we have only 2 oxygen here. So what we need to add, 2 more oxygen to balance this. So we'll add water. So we're going to add water, so we'll add 2 water. Okay, plus, so 2 2 minus. Okay, so we've added water here, so now we have our oxygen is balanced. We have 4 oxygen here, 2 oxygen here, 2 oxygen here. We have 4 oxygen on this other side. So we now know that our oxygen is balanced. So we need to balance this hydrogen that we have introduced, and this we have 4 hydrogen here, right? 2 times 2, 4. 2 times 2, 4. So we're going to balance the hydrogen. So on this side, we're going to add plus 4 hydrogen. Good. Now we've balanced. This looks balanced. Okay, we have 4 oxygen here, 4 oxygen here, 1 sulfur here, 1 sulfur here. We have 4 hydrogen here, we have 4 hydrogen here. So we need to balance this charge. Okay, on this side we have a net charge of 0, right? We can see there is no charge here, so we have a net charge of 0 on this side. So our charge here is 0, while on this side we have a net charge of -2. This -2 plus, this is 4. Okay, so plus 4. So we have a net charge of -2 plus 4, so we have a net charge of +2. So we need to reduce this net charge here and make it 0, so that both sides have to must have net charges. The total net charge on both sides should be 0. Okay, if this is 0, here has to be 0. So we have to rewrite our equation this way. So we have 2 water plus SO2. So if we balance this will be SO4 2 minus plus 4 hydrogen plus. So we need to remove this charge, right? So we add 2 electrons. Now our equation is balanced, so we have a net charge of 0 here. So here, let's say if our charges are balanced, we have minus 2 plus 4 minus 2. Okay, this minus 2, this 4, this minus 2, this 4 positives, and then here we have 2 negatives, minus 2. So okay, so we're going to have minus 2 plus 4 is 2 minus 2. So we have a net charge of 0. So we have a net charge of 0 here, we have a net charge of 0 here. So that's how you balance half reactions in acid solutions.